All right, so it's the definition of a limit in this video. We're not going to do a ton of them, but we are going to look at what are called epsilon delta proofs. They are not fun. I don't really enjoy them. I shouldn't judge them, but I'm not a big fan. But whatever, it is what it is. So we're going to start off we're going to do a couple examples of them. We're not going to do very many of them. My concern is that you've seen them. Okay, but here's the game. As you know, we have some function doing its thing. Here is, no, let's don't do that. Here's our function doing its thing right there. This is x equals c. The function may or may not exist at c. We don't care. But the limit does. Okay. There is some range where f of x exists. F of x exists on this interval, except maybe not at c. You with me? Maybe not at c. Maybe open there. Doesn't really matter. What we're going to say is, listen, we know what a limit means. We know is we are getting closer and closer and closer, right, to x equals c. That's what do we want to know what's happening. We're going to start calling these little areas here, we're going to call them delta. Okay? This is, if you will, c plus delta, and this is c minus delta. And if you go out less than delta, okay, there's some range there, you're going to get a y value that is some f of x, yes? Or maybe it's up here. Oops, clearly right there, yes. No. Some other f of x, right? But we know that the limit is right here. So what we're saying is that we get closer and closer and closer. In other words, x minus c, as it gets closer and closer and closer. In other words, as long as it's within delta, whatever delta is, units of c, then we should be able to find that the difference between f of x minus L needs to be within some value. And that value we're going to choose what's referred to as epsilon. Okay? And so there's a relationship between this delta and epsilon. Okay? And so the formula, now here's the problem. I will say this again. I started a video earlier and I choked out because kids I got a text and it kind of threw me off and I had to start over. So f of x equals L. We assume this limit is true. Assume this limit is true, and then we prove it that it is. It's basically what we're saying. We can't say that, hey, can you prove what it is? No, but I can try. I can't find what it is using this. I can't say, oh, the limit is 16. Okay, what I can say is if you think it's 16, I can then either prove or, disprove that it is, okay? So the limit of as x approaches c, of f of x is equal to L. I don't know what I was writing. That's the part I wanted to write, okay? So this is cute. Then if for all delta greater than 0, for all epsilon greater than 0, there exists a delta greater than 0 such that the absolute value of f of x minus L, that is the difference in the y direction, is less than epsilon if the absolute value, the distance from c, that our x is less than delta. Now that delta must be positive. Okay, we can't be at the point because the point again may not exist. Does that make sense? So this is going to require some algebra from us. Okay, so we want to prove this one, for instance. Prove that the limit as x approaches 3 of negative 2x plus 1 is equal to negative 5. Okay, so that's what we want to do. This is how we're going to start this out. So the first things first, we're going to look at this piece right here. Are you with me? So we're going to take negative 2x plus 1 minus a minus 5, okay, is less than some epsilon value. Well, that's going to be negative 2x plus 6. Now, what you're going to see is, for us, this statement here is always going to be this guy right here. So x approaches 3, that's x minus 3, right? That's what we're saying. And so what we need to do is we always need to look for some kind of an absolute value of of x minus 3 in there. Well, what we can do is actually factor a negative 2 out. And then because it's an absolute value, you can pull that out front. So you get this guy. That's cute. What I really want is this guy. Epsilon over 2. Okay? What we're saying is this. As long as this is less than this, we should be gooch. Okay? Now, what does that tell me? Again, so that's we've kind of basically we've picked our epsilon. We've picked our epsilon, had it picked for us. Our epsilon. That is the y direction, okay? So as long as you are within some epsilon over 2 in this direction, whatever that means, okay, then I guarantee you that we can be within some delta down here on the bottom, okay? And you're like, well, what does that mean exactly? Well, listen, we've started off with this. We are now going to go, we're going to find the delta we need. We need to find the delta we need. But it's going to be based on this thing right here. Okay? So remember, we are trying to prove this is true. So we're trying to prove that 2x minus plus 1, we need to prove that this limit is equal to negative 5. Okay? So obviously, so suppose, this is what we were told in the formula, suppose that epsilon greater than 0 is given. In other words, we already know that this is true, right? That's what we have to know. That comes from the formal definition of a limit, okay? Okay, so we are going to assume that this is less than some epsilon over 2. Now, why did I do that? Well, I got that from up here, yes? We're going to assume that that's true, okay? So if we go run back through the whole thing again, we say that the absolute value of f of x minus L has to be less than epsilon. That's what we're saying. So once again, we jump all the way down here. Now watch carefully. Here we go. Here we come. Here we come. And we get down to right here. 2x minus 3, like so, right? That's where we left off, right? Because we just simplified our entire thing. Well, let's run through it all. And then, of course, this is 2x plus 6, and then this is 2x minus 3, right? That part's all the same. Are you with me? Nothing has changed about that, okay? Piece of cake. But what we're saying is this has to be less than, well, wait a minute now. Hold the phone. Look what I've got right here. We assumed that this is true, yes? So you're saying that this statement would be the same as saying 2 times, and then what is a number that is bigger than x minus 3? Well, by definition, or by assumption, I should say, it's this. Does that make sense? We are saying that this number is bigger than this number. Therefore, 2 times this number has to be less than 2 times this number. Well, that means the 2's cancel out, and you get 2. Absolute value of x minus 3 is less than epsilon. Okay? Wait, what did you just do? What just happened, Jay? Well, listen, bro. This, where did it come from? It came from this. Right? Which is f of x minus L, right? You just proved that it's less than epsilon. What did you just prove then? You just proved this limit. That's all you're doing. We're going to run through some more. At first, well, not first. I will prove that. No, let me back that up a minute. This will always feel like you're going around and around and around in circles. Wait, what? I already know the answer kind of, but I'm doing it again. But yeah, Let's try another one. Let's prove that the limit as x approaches 2 of 3x minus 1 is positive 5. Sure, why not? Okay. Then the limit, anyway, so let's clean this up a little bit. So we know that f of x minus the limit has to be less than epsilon. That's fact. Well, that's 3x minus 6 less than epsilon. Oops. That's also a fact. Groom, we also know that x minus 2 has to be less than delta. Hey, that's awesome. Wait a minute. there's our guy, x minus 2. Is that always going to show up? Yes. So if x minus 2 is less than epsilon over 3, over 3, we should be gooch, yes? So what we're going to say again, what we're going to say is, obviously, epsilon is bigger than 0. We are going to choose delta to be epsilon over 3 this time. Okay, again, because of right here. Because of right here. Okay. Then we assume, based on that, then, that x minus 3, that x minus 2, rather, because of this statement and this statement is less than epsilon over 3. Okay? That cool? Nice. Now, if you come back up and start it all over again, right? So you get down to right here for just a minute. If you get down to right there for just a minute, okay? And you're coming along, you're like, all right, let's try that again. So I'm just proving the whole thing down again. Less than epsilon. Epsilon. Okay? Well, I shouldn't say it. Let me backtrack for a minute. You get all the way down to here, right? Right. Oops. No, you don't. You get all the way down to right here, I should say, right? So if you started here and you get down to right here, okay, I'm just going to come down to here, though. I'm not worried about this side right now. I'm only worried about the left-hand side. So 3 is less than x minus 2. You with me on that? All right, cool. Awesome. And so then what do you got here? What you're going to have is less than 3, again, because of this, 3. And remember, x minus 2 is less than epsilon over 3. Hey, those canceled out, Groom. I know. So 3x minus 2, like this, is less than epsilon. But this is equal to 3x minus 5 minus 1 minus 5, which proves the limit is, in fact, 5. Okay? A lot of times you will feel like you're just chasing your tail because you're like, wait, what did I just do? I feel like, duh. Sometimes that's true. Sometimes it will be kind of a duh feeling. Here is one that I want to do. That one. So the limit, as x approaches 1 of, what is it? 3x squared plus x equal 4. Okay? So right off the hop, you already know x minus 1 has to be less than delta, right? From right here. Okay? In our x direction, here's the number line, here's the number 1, and we're going to go some delta on either side. As long as we're within this delta up here, your function is doing its thing, and there's some lower limit. This is L. This is L minus epsilon, and then this would be L plus epsilon. And the idea being is the closer you get this way, the closer my vertical lines get to one another, to the L. That's what we're saying. So there it is. Yay. Nice. Now let's do a little algebra, because we love algebra. 3x squared plus x minus 4, absolute value, right, is less than epsilon. Wait a minute, Groom, I need to get an x minus 1 out of here. Well, I feel like you probably better factor then, dog. X minus 1. Is that right? Is it right? Well, in fact, it is right, I think, isn't it? Because if you look at it, you're like, oh, interesting. Yes, well, yeah, that should work, right? That factor is perfect. Now, this one, you'll notice, is a little different than last time. This one is a little bit different, so let's think about this for a minute. Here is the number 1. What would be a good delta to choose? Okay, well, maybe a delta of 1 just for fun. Now, Groom, is there any reason why I couldn't have done a half? No, it's too much work and I don't want to. Okay, but I could choose that to be true. So if my delta is 1, I'm over here to 0 or I'm over here to 2. What I'm going to do is I'm going to pick the bigger of those two values. Is it 0 or 2? When I put 0 in here, I get 4, right? And when I put 2 in here, I get 10. Groom's going to choose 10. So we're going to let x equal 2, since that is the biggest. Okay? So this is going to be 10 x minus 1 less than lambda, or epsilon rather. And so as you can see, it's going to be x minus 1 less than epsilon over 10. Just like before, that part's the same. The only difference is because this isn't a constant like it was before. Because that's not a constant, I have to then pick some variables. Now, I'll try it again in a minute with 0.5 or something, and you're going to like, do it's the same, it's just different, which is exactly the right answer. Good job. And so here we go. So again, what do we want to, we know we are given that epsilon is greater than 0, right? We're going to choose that our delta equals epsilon over 10 this time. You with me? And once again, we're going to get down to here, somewhere down in this neighborhood, okay? And we're going to see what's up on this guy. So 3x plus 4, x minus 1, epsilon, yes? Right? But I don't want the epsilon part. Now, what do we know? Okay, so we know up here, let's choose our delta to be epsilon minus 10. So x minus 1, boop, boop, epsilon over 10, right? So what does that tell me? What it tells me is that I can then rewrite this side over here, okay, as hang on, Mr. Groom's losing his train of thought for a minute. So 3x plus 4, right? 3x plus 4, times 10, because why? Oops, I'm sorry, times epsilon over 10, right? Epsilon over 10, like so. Now, Groom, what did we say about this 3x plus 4? We said that the biggest that could ever be is what? The biggest it could ever be is if this x was 2. And so we plug that 2 back into there. What do we get? We get 10 times epsilon over 10. And lo and behold, this is a strictly greater than problem. And it's strictly greater than, again, because of this guy. Okay? And so because of that, we've proved that this is less than epsilon. Therefore, you prove the problem. Okay? Oh, you dirty whore. Let's try another one. Okay? Now, I don't know. I wish I could see your faces. I'm sure some of you are freaking out. That's okay, Devin. We still love you. You're a great kid. You're an awesome kid. The limit as x approaches. I only talking to you because I don't want to make Parker cry. X squared plus x cubed equals 0. Obviously, right? Right? So you're going to get x minus 0. Yes? Is less than what? Delta. Okay? Interesting. Interesting. That's Pinteresting. So x squared plus x cubed minus 0, boom, boom, less than epsilon, right? That's how we set it up every time. Don't need the 0, but I can factor an x out, and I get x squared plus 1. True dat? True dat, homie. And, of course, x is less than delta, right? Makes sense? Okay, cool. Well, whatever. All right. All right, man. All right. Now, let's pick a particular value because, again, we are at 0. And we need to pick just kind of a starting, let's just pick kind of a starting x value there. What kind of a range would you like us to be on? Doesn't really matter. Let's try 0.5. 0.5. If that's true, let's plug that guy into here. Now, that's going to form the edges of our boundaries. Yes, as long as we stay inside those, we are gooch. So if I plug those in there, I'm going to get 1.25, I think. X, right, is less than epsilon, right? Make sense? Nice. And so I get the absolute value of x less than epsilon over 1.25. Okay, and you're like, okay, cool. What does that mean? Well, what it means, again, I see this same thing as I see over here, yes? So if I choose my delta to be epsilon over 1 1/4, I can prove this thing out, okay? And so once again, here we go. Here we go. So we're going to say that, all right, well, whatever. If I take this out and I go x, I'm going to write it as x squared plus 1 times x, like so, again, is less, I'm sorry, don't worry about it. I just get down to right here. Just going to right here. Now remember, what are we saying? We are saying that because of this and because of this, we are saying that the absolute value of x is less than 1.25. True that? And so what we are saying is this is going to be 1.25, right? You with me? 1.25 times I'm sorry, what am I saying? Yep. Well, yeah, that's going to be true. But what we're saying is because of this and this, what we are saying is that we can replace this and go, all right, so our our delta then, we can replace this and say, all right, so what we're saying is we're going to set up a relationship here. So it's still going to be the absolute value of x. Yes, that part's the same. And then, God bless, what am I saying? Just a minute, my brain is not working. Okay, so again, we are going to take the biggest of those two sides right here. You with me? Boom, 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 yes. And so we said that was 1 1/4. But what we're saying is this. If you take this right here, the absolute value of x, okay, is less than delta. But delta is equal to epsilon over 1.25. That means that if I replace this with this, then this becomes a greater than scenario. You with me? It has to be. It's no longer equals. And so because it's of that format, huzzah, we've proved that in fact it is a limit. Groom, does it matter what we choose here? No. The difference would be this. If I choose 1 and 1, if I chose 1 and 1, okay, we are at 0. So +1, -1, potato, vodka. You put 1 here, you're going to get 2. You with me? And this becomes over 2. You with me? And so now I take over 2. All right, cool. And then again, if I plug in the 1 that I get 2. And then I plug this back in, what do I get? 2. It's arbitrary what point I choose on those guys. Now, again, on the ones that it's easy, like a linear, you want to prove the limit as x approaches 3 of 2x plus 7 equals 13. You want to prove that? Fine. Here we go. Less than epsilon, right? And so if you do this, you're going to get 2x minus 6 less than epsilon. Also in my head, I've already got this picture drawn up, yes? Wait, I see this. 2x minus 3 less than epsilon. That's hot. That's it, baby. So x minus 3, boom, boom, less than epsilon over 2. I am going to choose delta to equal epsilon over 2, which means that x minus 3 is less than epsilon over 2. Okay? So that you're like, Grim, I know, I see that. It's literally here, but watch carefully. So what I mean is I'm going to come back from the top, and I'm just going to write this as 2x plus 7 minus 13. I'm ignoring the other side for right now. 2x minus 6, 2x minus 3. You with me on this? Now, what is this equal to? Well, I don't know. But if I put a 2 on this side, you're like, Groom, I totally get that. Because 2 times, interesting. But look at that relationship right there, baby. I can replace x minus 3 with epsilon over 2. Oops, and it's not equal, stupid. It's greater than. Yes, you with me on that? So what we're saying is that this guy here, which is this guy here, which is this guy right here, is less than epsilon. If you can say that's true algebraically, huzzah, our limit is in fact 13. Let's do another linear one. Some people are already crying. I don't know why you're crying. It's not hard. It's just stupid. At some point, you're just kind of like, Groom, this is too easy. I honestly, Groom, why do you make me do so many problems? They're so easy. I don't know. I'm a horrible human. -2. I have references. I am not a good person. There you go. Boom, 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 boom is less than epsilon. Yes. Also, we've got x plus 2 less than delta over here, right? So what are you going to have? 4x plus 8. Dude, I see it. Gosh, I hope you see it. Because it's obvious. Take a 4 out, x plus 2. Boom. I know. Let's choose epsilon. I'm sorry. So now I have epsilon over 4 should be greater than x plus 2, yes? That's cute. So we choose delta is equal to epsilon over 4. And because of that, the absolute value of x plus 2 is then less than epsilon over 4. That's it. And so then if we start off with just this piece again, because this is where the proof actually happens, I get 4x plus 8. I'm just doing the algebra part. This cleaned up to that. And then the next part cleans up to this. Okay. And so if I was going to make it equals, I could go 4 times. You get this. But look what x plus 2. The absolute value of x plus 2 is less than epsilon over 4. So what have you proved? You've just proved that the original thing is less than epsilon. What does that mean then? It doesn't matter what you do. We're off to the races. Mr. Groom, I choose my delta. Well, let's try this out here. Let's actually try this out. Let's choose delta equals 0.01. Let's just say that's true. If that were true, that means epsilon is 0.04. Are you with me? Okay. What does that mean, Groom? Well, let's say we are at negative 1.995 for our x value. You with me? Is that within this value? It is. Then I'm telling you right now, negative 2 plus or minus 0.04 is going to get us to negative 1.96 and negative 2.04. I am telling you right now that if you pick an x that is somewhere between negative 2.01 and negative 1.99, I promise you, you will get a y value that's between those two numbers. Let's try it. This is the whole point of doing this, is that's what we're saying. So you can always get it down. It doesn't matter which delta you pick, you will be within a certain epsilon. That's it. That's all we're saying. So our function was 4x plus 6. Oops, that's 44, Jay. Hey, that's hot right there, baby. That's hot. And look where our negative 2 is. Home. There it is. So we're right there. That's where we know we're supposed to be, is at negative 2. Now, Groom wants to do x equal negative 1.99. Damn it. And x equal negative 2.01. Well, that's cool. And if you zoom in on those, you're like, oh yeah, they're a little apart from each other. That's hot. And then let's hypothetically say, let's go y equal negative, what did I say? What is it? Hey, boo-boo. Let's get a little picnic biscuit. Negative 1.96. And y equals I said negative, damn it, equals negative 2.04. Oh. What does that tell me, Groom? It tells me, sir, that if you were to pick a value somewhere in this box, so between here at this one was negative 1.99, if you come along this, stop it. If you come along this line somewhere, I am less than 1.99, but I am greater than who? I'm greater than this guy down here, yes? And what I'm going to find is that the actual value of the function is right here, yes? That's the limit I was in question. And so what am I doing? I am saying that as long as I am between, I went over 0.01 one direction and 0.01 the other direction, yes? As long as I stay between those two boxes, my y's will always be at least within 0.04 of the actual limit. That's what we're saying. But Groom, what if I get closer? It's an excellent question, sir. It's an excellent question. What if you did get closer? Oh, got closer to me. That's right. Yes, I did. But 0.001 times 4 is 96 and 004. Oh, well, looky there, friends. We're just getting closer and closer and closer. That's all we're saying. That's all this thing is saying to us. It just formalizes what we said all along. All right, should we do one more? I guess. Sure. Let's do another, well, not that one. That was ugly. I'll leave that one for you in the homework. That one's not terrible. Yes. Prove. Oh, don't go to sleep, you hippie. Prove The limit as x approaches 2 of x squared is equal to 4. Nice, that's hot. So I'm going to have x squared minus 4, yes, is less than epsilon. X minus 2 is less than delta. Are you with me? Which means I got to see this x minus 2 over here. Oh my word, Groom, it factors. I know it factors. I made the problem. I know. Okay, cool. Now, 2 on the number line. Boom, 2, done. 3, 1. Are you with me? 3, 1. 3 and 1. 3 and 1. Question, which makes the bigger number when I plug it in for this guy right here? Well, 3 plus 2 is 5. 1 plus 2 is 3. So let's choose this guy here for fun, because that's the biggest that we're going to see. If we allow our delta to go up to 1, then our x then, because if our delta equals 1, we could get an x of 1, we could get an x of 3, again, on either side of 2, yes? So then the biggest, this can be is 5. Make sense? So I'm going to have 5 absolute value x minus 2 less than epsilon, which means I am going to choose my, there it is. So I'm going to say that delta equals epsilon over 2, you jackass, over 5. There you go, over 5. Nice. Which means that the absolute value of x minus 2 has to be less than epsilon over 5. Now, if you go back to the original problem, which is x squared minus 4, and you start simplifying it, well, that means that thing is equal to x minus 2. Damn it. X minus 2, x plus 2. And then again, if you, nice, ouch, ouch. And if you take this guy and you, again, you assume that the maximum that could be is when it was 3, so that would be a 5. These are all equals. Those are all equals. Now, if I just go, hey, let's write it sort of quote-unquote an equation, well, I'm going to have 5 on this side. That's cool. But I'm going to replace x minus 2 with epsilon over 5. But epsilon over 5 is greater than, so when I times it, it's going to be a greater than problem, yes? Therefore, what have I done? I have said then that x minus 2, x plus 2, which of course is, if you prefer, x squared minus 4, is less than epsilon. Wait, what have I done? Well, I have just proved that the limit is true. That's all we're doing. Not very hard. I'm not going to do a ton of them. Just want you to have seen it. It's a longer video than I probably would have did normally, but it is something you need to see enough of them of. All right, bye-bye.